Of this talk is automating your life with GitHub Actions, and here's what I'm going to talk about. I'm going to talk about what are GitHub Actions and why do you need them at all. How would you build a basic continuous integration pipeline? I'm going to talk about what continuous integration is. We're going to also build a little bit more complicated pipeline for automating your releases. So let's say you have a package that you want to release whenever you have pushes to the master branch. That could be done, and the versioning of it could be done automatically through GitHub Actions. If you have any questions throughout the talk, feel free to interrupt me. Otherwise, there's going to be a section for Q&A in the end. So, why GitHub Actions? Why do you even need to care about this at all? GitHub Actions have, at least for me, I think it's valuable because of three key things. It's automation. You can do anything with GitHub Actions, and like when I say anything, it's basically anything. GitHub Actions are something like a function in your programming language, in your JavaScript or anywhere, basically in any programming language. It takes some inputs and it gets triggered when some event occurs in your repository. Either that's a pull request, either that's an issue creation. I'm gonna probably open some docs, and that will be clearer later on. Security. So a lot of repositories use GitHub Actions to maintain secure contributions to their repositories. And this is also the idea behind continuous integration. You don't want to merge untested code into your repository. If some third-party developer comes in and says, like, I have this great feature that will improve your repository, you want to test that first, and GitHub Actions can help you with that. And stability, very close to security. This will keep your repository stable. So basically, if you have your pipeline built in, you can rely on GitHub Actions for doing all your work. You don't need to do it manually, and you can feel comfortable that everything will be fine. So the two concrete examples that I'm going to talk about today are these two pipelines that you can see on your screens. So first one is whenever anybody does a pull request to your repository, we're going to run some tests. If the tests fail for whatever reason, we will decline that pull request. We will not allow anybody to merge that pull request unless they are an admin of that repository. If the tests succeed, we will merge that pull request in case we're fine with the changes. So this brings like another level of security to your repository. Another pipeline that we're going to build is whenever there is a pull request that is being merged to a master branch, we're going to once again run the tests. We're going to bump the version of your software, and I'm going to talk about how versioning works for an example package that we're going to build. And we're going to create a release, and there's also a separate thing about GitHub releases and how that is built into GitHub. So it all works very nicely together, and we're going to see that soon. Okay, well, let's see what GitHub Actions look like. I have the slide here. This is explaining YAML, and this is the language that GitHub Actions use. You might have seen JSON before, which is object notation for JavaScript, and this is how you would transfer your data between your HTTPS requests or whatever you have. Like if you your package JSON file is written in this style, so you have your key value pairs, you have your arrays, and you can have strings in different formats. So this format is very great for data transfer, but not so much for configurations, although some packages use JSON, it doesn't really matter. GitHub Actions use YAML. So YAML stands for YAML Ain't Markup Language, which I think is just an amazing definition. It's like one of my favorite ones. It is recursive, and I think that's awesome. So it's very, very similar to JSON. You can see that at the top here we have our JSON file, which describes like a tree or something. And beneath we have our YAML file. So in YAML you don't have the curly braces, you will notice. And each key is denoted by basically a word in a column. And object relations are, you can identify them by tabs and indentation. So one key thing is that YAML does not support tabs. You would need to use spaces. If you ever enter a tab in YAML, it's going to crash. Where I'm going to create GitHub Actions is the GitHub website. It deals with it, converts all the tabs to spaces automatically, but be aware that if you create your actions elsewhere, you cannot use tabs. It's better for configuration. I don't know, it's like subjective. I don't really care which format the configuration is in, but maybe for some of you the bottom configuration is maybe nicer to the eye. Yeah, so if you at all have any questions about how this works, you can also see, by the way, I forgot to mention this, that there are 3 different ways to define strings in YAML, whereas in JSON you only have double quotes. You can either omit quotes at all, or you can use single quotes or double quotes, and you can also backslash omit some special characters within double quotes. Yeah, I think that's all about YAML. Let's actually look at how one of the actions might look like. So here, this is an example action on the GitHub Marketspace that we're going to use later today, but I'm going to just show an example of how an action might look like. So here you have your maybe now similar YAML, familiar YAML code, and you first define what will trigger your action within your workflow, and then you're going to say what steps do we need to take in order to achieve the workflow. And if all the steps do not throw exceptions, if they complete successfully, your check will pass. And it might not make sense right now. I'm going to show a simple example, and hopefully that's going to make it clearer. This is basically just to show you how a GitHub action look like. So yeah, we're going to dive into this. I'm gonna have a small set break. How are we doing? Okay, cool. I'm gonna move on. So let's look at the first example of what a GitHub action is. So let's see. I have a project here, and hopefully you can see the VS Code tab open. I'm gonna make the font a little bit bigger here. So this is a standard Node.js project, and what this does is basically has one JavaScript file which has a very complex method. It does one thing: it takes an input and it returns twice that input. So it basically multiplies the number by 2. If you look into, there's also another file which is index.js. This is the entry point of the app. It's completely unrelated to whatever's happening in that file. Doesn't really matter for the purpose of this talk, but we might work with it later on. If you're familiar with a standard Node setup, this you will not have any questions about this, but if you are first time seeing it, feel free to ask anything about this. I'm using, if you will look in my package JSON, which is like the configuration of the whole project, you will see that I'm using Jest. Jest is a very common testing utility for front-end development, and basically any JavaScript code you write, it's going to be very nice for you to test stuff with Jest. It works nice with Vue, it works nice with React, anything like that. So I have one test written here, and this says it imports our complex method, and basically what it does is it asserts that we have an expected result that's twice the input. Yeah, that's basically it. So it calls the function and asserts that. And that's about it. So what I can do with this, I can run node index.js, or rather node current directory, and this will say hi all. If you noticed in my index.js, that's what it does. I can also, sorry, I can also run the tests using npm. So if I say npm test, that will trigger this script right here. And it will run my Jest tests. So if I say npm test, you'll see that we have one test passing over here. And that's basically it. So it's like the simplest as it gets. The version that I was talking about and I'm going to talk about later on is this one right here. This indicates which version of software this is the version of our package. Our package is doing one thing, it's taking a number, it's multiplying it by 2, and at version 000. I'm going to explain what that means a little bit later. How are we doing? Any questions at this point? Am I going too slow? Am I going too fast? How does it sound?
All good for me.
Yeah?
It's all good for me.
Cool. Perfect. Okay, let's build an action. I was rambling about some JavaScript, and let's actually see it in action. So, explaining my Chrome setup right now, I have this tab configured for my profile, for my user, and this is, by the way, this is the GitHub repository for this project. I have also another Chrome tab, which I have another GitHub user under. I'm going to use that to showcase some pull request functionality later on. So the blue one is the main one, the white one is the guest. All right, so you will notice that you have a bunch of tabs at the top in your GitHub here, and one of them is Actions. So let's inspect what's in here. So right away, GitHub tries to show you what you can set up for your project, and there is like a lot of integrations with AWS, with Azure, Google Cloud, like Node.js. I noticed that this project is a Node project, so you can set up something like this. And this is actually pretty similar to what we're gonna set up. But I'm gonna set up a workflow myself, and this will make it clear. So what GitHub does for you is basically it creates a .github folder in the root of your project. I don't think you need the workflows directory. You might need it, I'm not sure. But I think the only requirement for the actions is to live under your .github repository. So this is explaining in detail what basically this GitHub action does. I'm gonna simplify, remove some comments, simplify, and talk about it myself. Yeah, I'm gonna just clean this up a little bit. We don't need this. Yeah, this as well. So this is a little bit simpler. So first of all is the name of your action. This could be anything. As you remember from the YAML explanation, you can specify strings without quotes, so you can throw in anything in there, like spaces, whatever you want. So I'm gonna name this something like PR confirm. Why not? And this will be something similar to PR confirm. So the first chunk of YAML will describe when your action is gonna trigger. This is basically saying that on push to the master branch, we're gonna trigger whatever's in the jobs part of the YAML. Also, if on pull request to master, also trigger these jobs. So the workflow that I'm gonna set up right here is the first one from the examples. So we're gonna, whenever somebody creates a pull request, I want to run the tests and then disallow or allow the merging of that pull request. So I'm gonna remove the push one for now. And I'm gonna just leave that whenever somebody does a pull request to master, we're gonna do this stuff. Jobs is also a reserved thing. Build is something you can specify. This key could be anything, and we'll see where it shows up later on. For clarity, I'm gonna probably rename this to something like CI verification. I'm not sure. Line 9 runs on Ubuntu latest. This means that your GitHub Actions gonna execute somewhere. It's not gonna execute on your computer. It's probably gonna execute somewhere on some computer in the cloud. Not to go into details of how containers work and how that all of that stuff is being set up. Imagine this line telling you that the computer that or the system that your GitHub action is gonna be executed is Ubuntu. This could be Windows, this could be Mac OS, whatever you would like. Usually you would just leave this as Ubuntu latest. I never encountered why you would change this. Maybe for some like specific, if your software runs on Windows, I guess, like, yeah, you would maybe use that. And then just your steps of what you want to do in your action. So this uses actions checkout line means that on our new system, this is up to this point, it's brand new. We're gonna just check out this GitHub repository. This is all of what this line is saying. I'm gonna do two things. So I'm gonna add two steps here. The first step, and I'm gonna name this. This is how you would name your step. I would name this install dependencies. And if you're familiar with Node.js, with NPM as well, the first things first you ever do in your project would be probably npm install. Right, so this takes whatever's in your dependencies in the package.json and installs that for you. Also generates the package log JSON file for you as well. Yeah, so that's what I'm gonna do. I'm gonna say this is gonna be my first step, and I'm gonna do run npm I or install. It doesn't really matter. So now, great, we have our project checked out. It's in our system and we installed all of the dependencies. Now we can do whatever we want with this. And what I'm gonna do is just simply run the tests. So run tests. npm test should do the trick. So as you have seen, npm test in our project runs jest, succeeds when everything passes. Cool, I think that's pretty much it. So I'm gonna just start a commit. That's fine, commit directly to master branch, and that's actually fine. Commit new file. Cool. Now I'm gonna actually switch to my other Chrome profile. So if I refresh this, we should have our GitHub workflows directory right here. That's the file that I just created. Awesome. Let's make some changes. Let's see this in action now. I'm gonna go into my complex method.js, and this is another user. This is not the same that I created the repository with. So I'm gonna go in here and edit this file. Let's first, yeah, sure. Let's make this fail first. So I'm gonna change this to 3 now. We didn't update the test, so this functionality will break the tests, and we will see that as the function runs. So I'm gonna say like change to 3. Propose changes. So we'll open a pull request against the master branch. And what we can now do is create a pull request. Change 2 to 3. Let's see, this might take some time on the first run. Here, we have a check that haven't been passed yet. And actually, I'm gonna view that from the other account. I'm gonna go to pull requests, change 2 to 3, and then I'm gonna look at checks. And this is like a real-time view of what's happening in our check. So we can see that it set up a job, it ran actions checkout, so if you check out the repository, and now it's installing dependencies right here. Dependencies probably take the most time. There are ways to minimize that. We ran the test and the tests fail. So why did they fail? They failed because you can see the jest is displaying that 290 is not equal to 435. And that's exactly what we changed. We changed 2 to 3, and now we expect a different output, right? So what does that mean? Our check failed. Let's go back to our user who created the pull request. Right, so actually this might be perfect. I thought I would need to do another step for this, but maybe it's not required. I'm not entirely sure. So the checks failed, and you can see that there is no way we could merge the pull request. So this is basically protecting whoever created the pull request. Even if they are the maintainer of this repository, they would not be able to merge the pull request. Actually, I'm going to verify that. I don't really trust this. So I'm going to add this account as the maintainer of the repository. So I'm going to go to settings, to manage access. Okay, let's see, I'm gonna give the right permissions here. So now my second account should be able to write to the repository. And yeah, I think we still don't have the merge button here, although this, oh, okay, it took some time. So we still, that's what I expected. We still can merge the pull request, even though the checks haven't passed. And this is not very good because you should not be able to merge a pull request without the passing checks. So from the maintainer's profile, I'm gonna go into branches, and I'm gonna add a branch rule. This is a little bit tangential to GitHub Actions, but this is a very neat way for you to protect your branches. So I'm gonna say require status checks to pass before merging. CI verification. Cool. I'm gonna hit create. Ooh, name can be blank, rules required. Right, I need to give this a branch name pattern. Let me see. I did not test this before, which is great. Let's see. I don't know. PR application. Yeah, this is also if you want to add extra rules like force pushes if the checks failed. Hope this will allow me to do this. Huh. Well, that's not very good. I wonder if... Yeah, I'm not entirely sure. What if I do master? Will this work? Oh, okay. Sure. Okay, so it just need the master branch to be written in here. I guess that's the branches that you target with your rule. Let's see if this works. I'm gonna update this. Look at this. We have this button disabled. I cannot click on this. And it says that required statuses must pass before merging. So I think from this account, I still will be able to merge the pull request. Let's see. Yeah, from here as an administrator, you may still merge this pull request. So it's like forced merging, but like, look at how GitHub is showing, like screaming at you that you shouldn't do this because some of the checks failed. Let's fix the checks and see everything be green and good. So I'm gonna go into this branch, which is patch 1 or whatever GitHub created for us. View all branches. Oh, interesting. This might be, okay, I'm gonna do this from here actually. Let's fix this back. Let's go to our complex methods. Can I? This can't be right. Should be a branch that was right here. Okay, that's, oh, it created a, interesting. It created a fork from the repository, and this branch is living like on a fork on this profile. Anyway, gonna change the 322 back, and we're gonna fix the pull request. So now, if we change this back, our test should pass and the checks should pass again. So I'm gonna commit the changes. I'm gonna go back to the pull request actually. So yeah, you can see that the action automatically reruns every time there is a new commit to the pull request. So that's the rule that we set up. Like if whenever there is a pull request or an updated pull request to your master branch, your rule will run. Let's see how this does. It's installing dependencies, running tests, and the tests pass, and our action passed as well. So now if I go back to the conversation, as a maintainer of this repository, I can merge the pull request. So yeah, this is basically to protect your branch from unwanted changes externally. And this is like probably the most basic thing and the most common thing people do for their repositories. Whenever there's an external person who comes in and wants to merge something in, they need to pass the tests first. Cool. Before I move on to the second example, any questions at all about this? Anything unclear? I assume all good? Cool, amazing. Let's do another interesting thing. So, gonna go back and yeah, you might have already noticed that in our workflow right here, we're using something external. this action/checkout at v2 is probably a repository somewhere. And this is something that somebody built, probably people at GitHub, for you to use in your actions. And actually, if I go to actions and I'm going to try to create a new workflow, set up a new workflow, you see that there is a marketplace of different stuff you can do. You can close state issues, you can download a build artifact, whatever that means. First interaction, cache, which I haven't explored yet, but I suppose that helps you to cache your dependencies as you execute the actions. So there's a bunch of actions already built for you, which you just need to include in your workflow file, and it's going to do all its job for you. So the second example that I'm going to show is actually this one, which will do whenever we merge something to master. We'll run the test, confirm that everything is good. We'll bump the version on GitHub, and we're going to create a release that anybody could download whenever. I'm gonna just quickly explain what versions are and how to understand them, and then we're gonna create that action. So samver, versioning, semantic versioning, all of that basically tells you how to read different versions of software. Usually, in like the majority of cases, your versions consist of 3 numbers. It's your major version, minor version, and patches. And on this graphic right here, it's explained somewhat well that major version will be increased whenever you have major changes which are breaking your API, breaking your interface that you communicate with your that anybody can use from your package, from your software. Minor version is that there are no breaking changes. You probably added a feature, something like that. So nothing was changed. Even people that were using your software before you changed it right now, they can still continue using it, and that's the minor version bump. Patches are basically like bug fixes, and they also don't impact the usage of a feature. They might fix something that was not working correctly, basically. And then there is also beta and some metadata versions, which I used sometimes, but we're gonna focus on this layout right here. So you have your major version, minor version, and your patches. So the end goal is to have a system in your GitHub where you can push something to master branch, and that's going to automatically create a git tag for you, version your software, and also create a release. And it's gonna be clear what that is by the end of when we build the action. So for that, we're gonna use a community build action, which is this tag release on push action. GitHub action to create GitHub release on pushes to master. We can see a simple example of how to use it, and actually I'm gonna start from this. I'm gonna copy this over. I'm gonna create a new action on our repository. So I'm gonna say release on merge or something like that. So this will be release and version on merge. I don't need this. And in fact, I'm gonna just replace all of this with whatever I have here. Whoops, did not copy this. Here we go. So whenever there's a push to the master branch, we will use this action. So this part right here is new. And this is basically setting up your environment variables to use in other actions. Some actions will require that as they execute. The GitHub token is being generated automatically. You don't need to specify anything for it. This will just work. But so you know where the secret variable comes from and what this notation means, this is basically saying replace whatever will be here with the secrets.github token variable. Your secrets live in your secrets tab right here. I can create a new secret, and it's basically like a key value pair that you can create for your repository. It's going to be hidden from the outside world. This is something to use in your GitHub Actions, and I think you can also access it from code if you want, but I'm not entirely sure. Primarily, I've seen this being used for GitHub Actions. So this is something that you can say, some keys that you can set, or like passwords, or if you're publishing an npm package, it will be your npm auth key. You're gonna dump something in here, and this is what the secrets variable means. This is referencing the secrets tab in your settings. So it's saying like get the GitHub token and set the GitHub token variable to that. And once again, we don't need to worry about this. This is being generated automatically. Now this step is what we see in our steps initially, and this is saying like use this repository. If you remember, you can actually go into our other first workflow. You can see that the first step that we had in the first workflow is like uses actions checkout. So this is using this action and running whatever it's doing. So we're basically like importing this package. This would be a valid analogy. And we're gonna pass some parameters to it. So we're gonna say that bump version scheme minor, and this is being explained in the documentation here. Bump version scheme could be minor, major, patch, or no release. So minor, major, patch will bump the appropriate version. So either the first number, second, or the third number. And no release will do not perform any bumps. It will not create a release as well. Like it to labels on pull request. Yeah. So the magic of this branch is that it will. This is basically saying like by default use minor. I'm actually gonna change this to by default not to create a release. So I'm gonna change this to no release. And it's saying that by default do a no release, but this variable will be replaced with whatever label we place in a pull request. And I know it sounds strange, but you're gonna see this work, and it's just amazing. Like you can read any metadata about what is happening in your GitHub repository by these GitHub actions. I'm gonna actually also name this, so I'm gonna give this a name, bump version and release. So by default it's gonna perform no release, but if there is appropriate label, and once again this is being described right here, if the PR label is release major, minor, or patch, this will override the bump version scheme right here. So whatever this is the default property which you specify in your action, and when we're gonna add a label to our pull request, this will override this input magically behind the scenes. Also, if there's some extra steps here, so these two are taken care of. Now the only thing I need to do is run the tests before doing all of this. So this is, I'm gonna actually just copy this part, and this is what we will need to set up before. So we check out our repository, we install our dependencies, test everything, and bump the version and release. I think that's everything actually. I think this just might just work. So you will see that like our trigger is on push to master, and right now I will push to master, and this action will trigger. Once again, like we'll see this running. By default, it's not gonna create a release, so hopefully we'll not have anything being done to our repository just yet. So I'm gonna commit this new file. And let's go to our Actions tab on our repository. So we'll see that this action straight away is gonna be run. Let's see what it does. Okay, this might take some while. I'm gonna take a sip. Okay, it's checking out our repository, installing dependencies. You can see that the name of this action, release and version on merge, is whatever the name we specified in our YAML file. Okay, cool. So bump version and release happened. Like it skipped release. You can also view the logs of your steps, which is amazing. Like you can see where your actions failed, where your steps failed. You can see that we ran some release functionality. This is some behind the scenes that the package was doing for us. And we can see that it skipping release, no version bump found. Awesome. Let's create a pull request, add a label, and try to merge it in and see what will happen. So I'm going to go to the pull request that we just created here. I'm going to add a label to it, which will be release. And let's say it's going to be like a major version. So right now, our version is 000, and we expect that it's going to be 100 because we bumped up the major version. We don't have a label with that name, so I'm going to create one. What do I feel today? Yeah, that's good. Cool. So we have a label over here. Ooh, this branch is out of date with base branch. Let's see if we can quickly fix that. If not, I'm going to just create a new one. I'm going to need to wait for the checks to pass. This is the only annoying thing with GitHub Actions, is that it takes forever to test them and forever to like wait until they are complete. But the costs, the reward that you're getting is basically like security and stability, and you can rely on your repository if you have everything automated. Versus you would imagine that without GitHub Actions, the maintainer of the repository would need to go check out the pull requests, run all the tests, which might take a lot of time, and also verify that everything is okay, besides just reviewing the code. So it takes time to develop the actions, but it takes a lot of your time it takes off of your time when you're developing. So I'm going to just merge this pull request. Let's see what happens. So I'm merging to master, confirm merge. Okay, let's see if our action got triggered at all. And we see that it did. So we merged the pull request, and our action of release and version on merge got triggered. Let's see how it runs right here. Building, running the checkout. I'm gonna actually showcase the titles once again. So we specified, so release and merge is what's shown. No, actually it's release and push. I guess it's, yeah, it's the name of the job that we're executing, and then the release and version and merge, the name of the whole action is displayed right here. Cool, we successfully did everything, and let's see what this says. Hey, look at this. So our new version is 1.0.0, so it detected the label on the pull request, and it detected it's the major version bump. Furthermore, what this means is now if I go into the code, you will see that we have an automated release here with a tag on our git commit. So this basically lists all the commits since the last version, since the last release, and it will create a special tag for you on the commit message, which you can view from your repository from. I think this is awesome to include in your projects if you want to do versioning, or if you want to build some easily maintainable software where you have everything automated and you don't need to like deploy everything manually and bump the versions and stuff like that. So I think that's just amazing if you do this often enough as well. I'm gonna note one or two problems with this in which you might want to improve this repository, and this is public on our GitHub organization, so feel free to pull request or change this. Two problems that we have right now. If you go into the package.json file, the version is still 0.0.0. So you can see that even though we have created the tag and everything in the release, the package.json version did not get affected. And this is something you can also automate with GitHub Actions. You can research what GitHub Actions bump package.json versions and include that in our workflow. Another thing that I mentioned before, I'm not very sure if that will work, but from the description of this, I hope it will. You can see that every time we're checking out and installing dependencies and all of that, there is this, actually it's not, for the time needed, it's not being shown here, but there is a cache action, which basically cache artifacts like dependencies and build outputs to improve workflow execution time. So this is something else which you can research and look into. Yeah, so this is up public. If you want to do PRs or play with this, feel free. If you have any questions at all, I'm here for the rest of your time.